All right, turn your textbooks, if you would, please, to page 152. We're going to continue our Chapter 1 review, or finish up, I should say, our Chapter 1 review, all that information from those first couple of tests, as we look ahead toward an exam. And then we'll get into some new material here in just a little bit. But page 152, number 17 through 24 at the top of the page. Page 152, number 17 through 24 there at the top of the page for classwork. Take about 5 to 7 minutes or so to work on that, and then we will take a look at it together. Now it's Christmas season. Bless you. Did you feel blessed? just a couple more minutes to be finishing up. Obviously, you're totally stuck on something to move on. Be prepared to ask questions later. pause where you're at. I know some of you are still working. Questions on the first four, 17, 18, 19, 20, all the practice with fractions. There was a big emphasis on our second test, fractions. Multiplication of fractions, factor and cancel. Remember, if you cancel something out of the bottom, set it unequal to 0. How many got this on number 17? Any questions? Number 18, it was monomials. They were being divided, though, so we multiplied by the reciprocal, so I flipped it, canceled stuff, just have a lot to keep track of here, right? And when we end up working it all out, end up with a 3, g to the 9th, x to the 13th over 10, a to the 7th, d to the 4th, m, y to the 7th, g canceled out of the bottom, x canceled out of the bottom. So we'll specify that those cannot be 0. How many got that answer for number 18? All right, a lot of little details to miss. Any questions? Yes, ma'am.
Can you kind of go through, because I completely didn't even remember how to solve it.
Yeah, absolutely. All right, so we understand the flip, right? It said divide, so multiply by the reciprocal. So I'm looking at the numerator with denominator. I'm like, well, there's a 5 in both 15 and 25. Take that out to get 3 and 5. I got 7 A's here, 14 A's down here. So if I knock out 7 of them here, I got to take out 7 of them to leave them with 7 more. These 4 D's cancel with 8 of these D's. I still have 4 D's. These 3 G's cancel with these 12, but I'm left with 9 up here now. This y ended up canceling with this y to the 9th to get a y to the 8th, and now it's gone. Then I came over here and said, well, here, 1 and 2, 11 comes out of the 11 and the 22. M to the 6th, m to the 7th, take out 6 m's from both spots, but I still have 1 down here. This 1x can cancel with one of these, so I still have 13. And then this y canceled with one of the 8 y's now to leave me with now just 7 of them. So then it's multiplied. I got a 3, a g, and an x to the 13th, so 3gx to the 13th. Here the numbers combine 2 and 5 to get 10, and then alphabetical. A, then the D, then the M, then the Y. And then I just went through, are there any letters that vanished? M is still here, Y is still here, X is gone. X can't be 0. A is still here, D is still here, G is gone. G cannot be 0. And then even looking up here, this was an original denominator. Did any letters vanish? Well, M is still in here. Y is still in here. X is already specified cannot equal 0. So we didn't have to worry about that necessarily. Does that make sense? Remember it now? All right, questions from anyone else? Come to the next one. The next two, really. Adding fractions, or in this case, it was a subtraction problem. Got to get a common denominator, but factor first. Get the factors. X negative 8, X positive 4. This is just X positive 4. So the LCD is X negative 8, X positive 4. Everybody needs representation. Well, nothing changes. So, nothing changes. But here, I needed to multiply the X negative 8 to make it match. So I also multiplied by X negative 8 in the top and got all of this ghastly mess. Again, they're not similar binomials, so I get a 4-term, first, outer, inner, last, nothing combining. I could combine the 3x and the negative 72x at least to get a negative 69x. These terms really could be in any order you want them to be. I try to descend them more or less. You want a positive first term, of course, and then the x negative 8, x positive 4 in the bottom. How many got that on 19? Questions on 19? No, not as many hands that time. All right, questions, or you say, well, now that you went over it, it makes sense. Okay, any questions? Next one's very similar. It was a subtraction problem. I made this adding the inverse, so I changed this to a positive, this to a negative. Well, same thing, factor, x negative 8, x positive 5, and then keep the factor of x positive 5. Obviously, x negative 8 gets represented, x positive 5 gets represented. This x positive 5 is already covered. So nothing changes, here. Then here, I needed to multiply an x negative 8, so I multiply the x negative 8. That FOIL actually works out okay. Combine my terms, and at first I looked at this, I was like, ooh, I wonder if it factors more and they're trying to trick me. But then I realized, can you possibly split up a 28 to get you a 5? What about, can you split a 28 to get you an 8? No. So even if I could factor it, it won't cancel with one of these. So, yeah, we're done. How many got this answer on number 20? How many this answer on 20? Are there any questions on 20? Say I didn't get it and I'm still a little confused. All right, continue working on the 21 through 24. That's radical problems. I'll put those up in just a moment. How many are finished with the exercise now? Okay, most of you are still working then. All right, continue working. If you are finished, you can sit there with a smug look on your face. for sake of time, pencils down. We'll look up this way. Let's take a look at the last 4 problems, 21 through 24. Basic radical reduction. You got to factor it, right? And it's looking for a 5th root, so squares don't help, cubes don't help. I need something to a 5th power. We memorized 2 to the 5th is 32. So if I factor this into 32 and 2, I can take the 5th to the 32 to get 2, and I'm going to leave this other 2. Also, 5 goes into 6 one time with 1 left over. How many got this on 21? Questions? Number 22 is kind of more of the same, where we have to reduce the radicals before we can add them. Remember, you cannot add dissimilar radicals. So I'm going to have to reduce them. Both of them out of 16, so I know there's the cube root 8, right? 2 cubed is 8, so 8 times 2 and then 8 times 2 here. Cube root of 8 is 2 in both cases. Leave the other 2 in both cases. 3 cannot go into 2, so leave both A's. 3 does go into 3 once with nothing left. 3 goes into 5 once with 2 left. 3 goes into 4 once with 1 left. And then I looked at this and I'm like, wait a second. They're still not similar radicals. I guess we're done. Can't add them. There we go. It's kind of, feels like a waste of time. But anyway, how many got this answer for number 22? Questions? My problems work out better than that. All right, looking at the next one. Multiplication. You ain't got to do nothing to multiply. You just multiply. So I multiply the coefficients. That's where I got the 12x squared y to the 7th. Multiply the radicands. That's where I got the 40c squared xy to the 8th. Needed to factor the 40. It's a square root, so squares are good. 4 times 10 is fine. Pulled out a 2 from the 4 to make this a 24. Left the 10. And then the x squared, well, let's go in order alphabetically. 2 goes into 1 time with no c's left. 2 cannot go into 1, so the x stays, so this x squared just remains x squared. 2 goes into 4 times, so 4 more y's to give us 5, no y's left in. And there's our answer.
Isn't it? It's 11.
There was a y to the who?
You forgot to pull down the 7 y's. Yeah. You just pulled down 1.
Oh! Oh, right here. Oops. Okay, yep, there we go. Okay, so I forgot the 7. So that's 4 more y's would give me a y to the 11. I was just seeing if anyone was paying attention. All right, good job. How many had this answer on number 23? All right, how many of you have been waiting for me to go over so you could say something? All right, I knew you would be, Michael. Good. Hey, somebody's got a fact check, right? Somebody's got to be watching. Thank you. Looking out for me. All right, questions on this? New favorite student, but I'm still not giving you the note I gave her. All right, all right, question. Poor Genesis. All right, questions on this. She's not giving me a gift Christmas tree cake next time. All right, look at this one here. We got a 2-term radical denominator. Got to multiply by the conjugate, 6 negative square root of x. Square the first, 36. Square the last, x. Put a minus sign between them. Can't do anything with it, so it's just going to stay 36 minus x. In the top, you got to FOIL. First, outer, inner, last. Nothing combines. But I can't leave a negative first term. So my choices were either factor out the negative or put a positive first. So I'm like, well, this is a positive. I'm going to put that in front. So I slid that in front, and that way I don't have to worry about it anymore. How many had this or some rearrangement of top terms to go there? I guess technically descending order, this is the 1.5 power, first power, half power, 0 power. So technically descending order should have been this, 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 this. We weren't going to factor anything anyway. How many had this for the last one? Those who made it all the way to the end. All right, questions on this? Any questions on that chapter 1 stuff that we were reviewing? All right, well, let's get into some sort of new material. I want to take you back, though, to linear inequalities. And inequality, remember, we said is just like an equation, except if you divide by a negative class, you flip the inequality around. So a less than would become greater than. A greater than or equal to would become a less than or equal to. But otherwise it solves just like an equation. So in your notes, if I had 3x plus 2 is less than or equal to 5. Well, class, I would first
subtract
to get
3x is less than or equal to 3.
and then
Divide by 3.
to get,
X is less than or equal to 1.
there we go. I didn't divide by a negative, I don't flip it. If this had been a negative 3x, well, for one thing, this would have been a negative 1, and I would have flipped it to make it a greater than or equal to, if that had been the problem. Make sense? We remember this? We also talked about compound inequalities, remember, where we had something maybe like a negative 7 is less than or equal to 2x minus 5 is less than 0, or something like that. Where here, let's make it a 10, because that's what I have on my notes. It doesn't really matter. But here, remember to solve for the x. I forget the x by itself by first class.
Adding 5 to both sides.
Adding 5 to all sides, or all pieces, right? There's not necessarily sides here, there's just parts of the inequality. So we end up adding 5 to everything to get less than or equal to 2x is less than 15. And then divide everything by the 2. And these were the ones we hated when it was negative, right? Because it would flip everything, and we have to flip the whole thing around again. That was annoying. We get negative 1 is less than or equal to x is less than 15 halves. Now, this is solving it, but then we also had something called interval notation, where we look at this and say, well, if x is great, well, let's go back to the original problem, because this is what you all had on your paper. Okay, if x is less than or equal to 1, like you had on your paper, less than or equal to 1, then that means it's 1, and then everything less than, or everything smaller, all the way down, class, to negative infinity. And so from negative infinity on the number line all the way up to the 1, give me solutions I can use. On the infinities, remember we said we're always going to put a parenthesis. But if we have an or equal to, we'll put a bracket. And that's how we would write the interval. Remember this. So here, for instance, it's a closed interval. This is an open interval because it goes all the way to negative infinity. This one's bounded or closed, or unbounded. This one's bounded between the negative 1 and the 15 halves. Be a mixed interval because it's going to be part closed, part open. But here, remember, we put the first number, comma, second number, bracket because of the or equal to, parenthesis because no or equal to remember this. All right, so are there any questions on basic inequalities before we take the next step with these things? Remember this? All right, so next thing in your notes, actually, you know what? Let me let you practice these. Let me make sure we're good. Page 143. Page 140. It'd help if I could read my own notes, but you know. Page 143. I want you to do 3, 4, 8, 10. Page 143. 3, 4, 8, and 10. These are all just basic stuff we've done earlier. Write your answer, though, if you would, as an interval. Check your answers to 3 and 4. How many got both 3 and 4 correct? You got both of them right. All right, how many got at least one of them right? All right, questions on either of those before you continue? All right. I just read they don't have any or equal to's in any of these. So everything's parentheses. Got a little issue on number 10, something we had not seen previously. We have m's everywhere. We don't work with m's everywhere. We have a letter in the middle, right? So if we can't have m's everywhere, class, then that means we're going to have to get rid of the little m. Or we could say get rid of the m's that are on the edges here, right? And to get rid of those m's, we're going to need to add a 2m to everything first. We hadn't seen anything like that before. And frankly, it only can work if there's the variable that matches on the outer edges. And of course it does. That's something a little different than what we've seen. And there we go. All right, questions on 3, 4, 8, or 10? All right, now, before Genesis falls asleep with boredom, let's take it up a notch and let's go to something a little more interesting. Quadratic inequalities. Quadratic inequalities, the next section in your notes. Quadratic inequalities. Obviously, quadratic inequalities would be an inequality in which there's an x squared as the highest power that stands to reason. I don't even know that you need to write that down necessarily. But the key with a quadratic inequality is that you're going to start, just like a regular inequality, Maddie, is solved like a regular equation, but one little difference. So a quadratic inequality, class, solves like a regular quadratic equation, but with one little difference. So your first step in solving a quadratic inequality is to set equal to 0. Not really equal, we understand that. It's an inequality, so it's going to be a greater than, but set it to 0. Make a 0 be on one side. Make sense? So that way we can solve like normal. So for instance, as an example, if we had this problem, if it were an equal sign right there, you'd say, well, bring the 4 over to make it a 0, right? Well, we're still going to do that. It's just not necessarily equal to 0, it's greater than or equal to 0. So the first step is what you'd expect. Step number 2, you can probably guess, class. Factor. So we factor. And x and positive, negative. We want the 1 to be the positive, the 4 to be the negative, right? Step number 3, set each factor equal to 0. Now here I don't necessarily put the equal to in quotation marks. You're just going to set them each equal to 0 to get 2. They're not actually answers, but what do we get for x, class? X is equal to negative 1 and 4. And number 4 then, solve, but. Solve, but these are not answers. Right? You can't possibly solve an inequality which gives you ranges of values on the number line and come up with 2 concrete answers for x. It's got to be a range or ranges of answers, right? These are not answers. They are separator points on the number line. And that's the one difference. Everything else is like a quadratic. The only difference here is when we get our quote answers, they're not actually answers. They're separator points on the number line. The term the book uses for these are your critical points. So on the number line, and I actually will draw a little number line here, and I'm going to put my -1 critical point and my 4 critical point on the number line. These are separator points though. They take what was one continuous number line, and if I chop it once, twice, how many pieces of number line do I have?
1, 3.
3. Right? If you have something and you cut it once, you have 2 pieces. Cut it twice, you have 3. There's a piece, everything right here, right? This is one possible piece of the number line. This is another possible piece of the number line. And this is another possible piece of the number line. See, there are 3 pieces. Step number 5 is to write out all ranges of values, which there should be 3 of them in a quadratic. So we've got from -infinity up to -1. We have from -1 to 4, and we have 4 to infinity. And since there's an or equal to, which we didn't see in the classwork a moment ago, brackets everywhere except the infinities. Those are my 3 ranges of values. My answer is not the points. My answer will be either this range, this range, this range, or possibly more than 1. Make sense? So what we're going to do is figure out which range works. Well, the best way to do that, number 6, is to pick a test point from each range. Pick a test point from each range and try it in the original inequality. Pick a test point from each range and then try it in the original inequality. Pick a test point from each range, try it in the original inequality. So we need a point, any number you can think of, class, that is between -infinity and -1.
-1.
Well, you can't use the separator point. You're right, it's technically in the range, but the separator points will always check. So, and if it's not got the or equal to, it'll never check. So that doesn't really tell us anything.
-23.
Okay, now if you want to pick -23, you can. So -23 squared. Michael?
Oh, yeah, no, we're good.
Okay, so maybe -2?
Yeah.
Or even 10. I like 10. That's an easy number to work with. Why don't we try that? What's -10 when you square it, class? 100. And -10 times -3 is greater than or equal to 4. Is that true?
Yes.
Yeah. Any value, even -23 would have checked. -2. Any point that we try here would check. Let's try a value between -1 and 4.
2.
We could try 2.
1.
I like 0. I love 0. 0 is my favorite. Because bam, 0, bam, 0. Is nothing greater than a 4?
No.
No. Okay, so I already know it doesn't work. But we could try 2. 2 squared, 4. 2 times -3. Is 4 minus 6 greater than or equal to 4? No. But 0 is easier to use. So we're going to cross that guy out. He's not part of our answer. Let's try something between 4 and infinity.
10.
10? All right, so we square a 10, 100. 10 times -3 is greater than or equal to 4? Yeah. So this time my answer is this range and this range. Anything in those 2 ranges will satisfy that inequality. And that's how you solve a quadratic inequality. Set it to 0, factor, set the factors to 0, solve. Everything's normal until right here. These will then separate your number line into 3 ranges. List the ranges, pick any number you want inside the ranges, preferably an easy number. Maybe you're really good at math. -23 would work, right? But pick a value. If it works, great, part of your answer. If it doesn't work, cross it out. It's not part of your answer. Let's do another one together. Do this one with me. X squared minus 10 is, plus 10, excuse me, is greater than or equal to 7x. X squared plus 10 is greater than or equal to 7x. It's a quadratic. Pretty much always with a quadratic class, we set it to 0. Now here's going to be greater than or equal to 0. And what do I write on the left-hand side? Anyone? All right, should be no questions so far. After we set it to 0, class, we factor. And it should be pretty easy to factor.
X raised to x equals 5.
Right, x negative 2, x negative 5. All right, then we set the factors equal to 0, like we always did to get x equals 2 and 5. But we're not done. In a quadratic equation, we're done. This is an inequality. So these are not my answers, class. They are separator points. So quick sketch of number line. Here's 0, here's 2, here's 5. Plot your 2, plot your 5. My first range of possible answers is everything down here, class. How would we describe this range? Negative infinity to 2. The next range is everything in between. 2 to 5. The final range is everything bigger. 5 to infinity. Questions on how we got the 3 ranges? Any questions? Don't want to lose anybody. We good? All right. Now we pick a random value. Some random, or not so random, number that is smaller than 2.
0.
I love 0. Thank you. So we plug in a 0. Bam, this is gone. Is 10 bigger than nothing? Yeah. Not so random value in between 2 and 5. Well, 2 is not between 2 and 5. Again, don't pick the number itself. 4, okay. Square of 4?
16.
Plus 10?
26.
Is 26 greater than or equal to 7 times 4? 28. Is 26 bigger than 28? Ah, I missed it by that much. All right, pick a not so random number bigger than 5. 10. Square of 10? Plus 10? Is greater than or equal to what's 7 times 10? Is 110 bigger than 70? Yep. So there are my answers. And this time, once again, it happened that the 2 outer ranges worked. Questions on this one? How many, now that you've done one with me, say, I think I pretty much got this? Let's do another one anyway. It's, not everyone's nodding their head yet. X squared is greater than or equal to 4x positive 21. I probably should have left that up there. Oops. All right. So step number 1, class. Set it to 0. And so let's keep the x squared, remember. Let's keep it where it is because it's positive. Bring the other 2 numbers over, the negative 4x, the negative 21, greater than or equal to 0. Then we need to factor. And whensoever we factoreth, we get x and x, positive, negative, 3 and 7. So what 2 separator points do we get for x, class? Negative 3 and 7. We go to the number line. We plot a negative 3. I'm making up for no or equal to's earlier. We plot our 7. And so my first possible range of values, class? Negative infinity up to the negative 3. Next possible range, someone besides Brandon? Negative 3 to 7, okay? Final range, someone besides that row? All right, we've got a little bit of quiet chorus action there between Audrey and Maddie. 7 to infinity, good. We pick a random number smaller than negative 3.
Negative 4.
Okay, square of negative 4? 16. All right, 4 times negative 4? Negative 16 plus 21. Is 16 bigger than 5? Once again, our first range works. Does it always work? No, it just happens. Seems like it's happening too in these examples. Pick a not so random number between negative 3 and 7. 0. Bam. Is 0 bigger than 21? No.
Let's do 23.
All right, and a 23 squared.
529.
529. 4 times 23?
Negative 92.
Well, it's positive 23, so it should be positive 9. Oh, you're plugging it in down here. I was going in up here. I got positive 92 plus 21. Is 529 bigger than 92 plus 21, class?
Yes.
Yes. So it checks out. And there's our answer. Negative infinity to negative 3, 7 to infinity. Questions on this? You ready to try one on your own? All right. At your seats, try this one. 2x squared. Oh, there's one thing I wanted to show you on this one. Well, I'll let you take it after we show it. 2x squared, positive 10 is less than or equal to 12x. You know what, I'm going to take off the or equal to. I keep giving you or equal to, so we keep using brackets. I want to make sure you... All right. Thoughts. If this were an equation, what would I tell you to do to simplify your life? Divide everything by 2. You can do that even in the inequality. So do that first step. And then take it from there. I'd knock the 2 out first, right up front. Make your life easy. All right, did we get these 3 ranges? Negative infinity to 1, 1 to 5, 5 to infinity? Any questions on how I got those ranges? Try a 0 out. Does 0, by the way, I'm going to cheat and I'm going to come right down here. Does 0 check out? No, 5 is not less than 0. If I try 2, 2 squared? Plus 5? 6 times 2 is 9 less than 12.
Yes.
This time, the middle checks out. And then let's try a number bigger than 5. 10. 10 squared? Plus 5 is 105. And then 10 times 6? 60. Ooh, and that will make a difference, because if you say 50, is 50 less than 60? Yes. But it should be a 105. Is 105 less than 60? No, so this is not checked. So we should just have the 1 to 5 notice in parentheses. All right, your homework this evening, you're going to try several of these. However, not all of the homework is quadratic inequalities. Okay, so you got some of the review, basic, easy stuff at the beginning, and just a few of these will actually be quadratic. Page 143 to 144. Page 143 to 144. Practice 1 to 16, the teal. 143 to 144, the 1 through 16, the teal colored problems. All right, have a wonderful rest of your day, and you are dismissed.